Hello, Math 7 students. This is your proportions review in preparation for your test. I probably am not going to have time to go over every single problem in this video, but I will make sure to post the answer key in Canvas. So after you do as much as you can with the video, then you can complete the rest on your own and check your answers. To get started, this is a typo. It is not Unit 1. This is actually Unit 2. So make that change. This is Unit 2 on proportions. And I want you, as much as possible, for you students that are here in person, you guys are going to be doing a lot of group work today. You're going to be doing a lot of discussion. But the thing is, I want you to spend today kind of treating it like a test. On a test, I'm not going to let you talk. But on a test, you shouldn't just be like, yeah, that's confusing. I'm going to give up and not even do that problem. Because if you do that on a test, you're going to get a 0. And a whole bunch of zeros is going to add up to be an F. So we need to make sure that even if it's confusing, you read it, you reread it, you write down the things that you know, and you try and figure it out. For this first problem, you even get the advantage of working with your table to do that. I'll read it to you, and then I expect you to get started. It says, in the following problem, one representation of a proportional relationship is given. Complete the other representations, and then use those representations to answer the questions that follow. It says one representation is given. You want to know the representation that's given? It's a story. There's not a table filled out. There's not a graph filled out. It just gives us the story. And the story is very short and sweet and simple. On a map, 1 centimeter represents 25 miles. Have you guys ever seen a map before? Like an actual map, not just like Google Maps. Okay. And there's usually a key somewhere on the map that will say something like this. So that when you're measuring 1 centimeter on the map, you don't think, oh, that's just 1 centimeter away. You know that that represents a distance of 25 miles. Okay, so there's your story. You need to complete the table, complete the graph, and write the equation. And then we'll answer those questions. How are we even going to get started here? I want you to take 60 seconds first, and I want you to try this on your own without talking first. Treat it like a test. Have that perseverance. Don't give up. Give it a try. After 60 seconds, then we'll come back together and we'll talk about it. But 60 seconds of your own work right now. Online learners, go ahead and pause the video. Give yourself 60 seconds of think time. All right, let's discuss, how do I take the information that was given to me in the problem and even get started? How do I put that in the table? What would you do, Jada? That is a great start. I'm going to add just one small change to that. What she said, for you online learners on the video trying to listen in, she said, it says 1 centimeter represents 25 miles. So I put on the table a 1 on this side and a 25 on this side. And then I just kept going down in the table following that pattern, which is great. But here's the one change I want to make. At the top of every table, we should have, Trinity, yeah, we should have our labels, right? So if, as Jada said, we're going to have a 1 here and a 25 here, what does the 1 represent? The 1 represents centimeters. And the 25 represents miles. And I'm going to help you out and kind of lead into another question that it's going to ask later on. Why is it measuring centimeters here and miles here? What are we referring to with the miles? Chandan?
So, if you're looking on a map, it's every 1 centimeter.
Yeah, on the map it would be centimeters. Exactly. Yep, so this is the centimeters measures the distance on a map, right? What are we measuring here when I'm measuring miles? Actual real life distance. Perfect. So I'm going to add those labels as well. And I know you guys like to use variables like X and Y. So we're going to also label them X and Y too. And as Jada said, she just continued on with that pattern. When she knew 1 and 25, she probably secretly, without her really even knowing it, asked herself, how does a 1 change to a 25? Multiply by 25. So then whatever numbers you choose, like 2, 3, 4, and 8, just to be different. How are you going to go across the table? You already know. Okay, and then with your groups, make sure that you guys complete your graph. Which one is the x-axis? Which one is the y? What are we measuring? How are we going to count? And then write your equations. Work with your groups on that. Online learners, pause the video until your graph, equation, and table are complete. Okay, let's go over this. I need you to come back together with me. 2, we go forward by multiplying by 25. So that's going to be 50, and I'm going to continue. 3 times 25 is, and 4 times 25 is 100, and 8 times 25 is 200. I skipped ahead. You might have done number 5. I skipped ahead to 8. And this is the what? X or Y? X. And what am I measuring in the x-axis? Centimeters. So we need to make sure that we list that as well as the x. Centimeters on the map. And this is, since this is the x, this one must be the y. Which means that we are measuring in the y-axis actual miles. So let's figure out ways that we can count. Let's see. On my table, it looks like I'm counting by ones. 1, 2, 3, 4. I did skip, but 1, 2, 3, 4 mostly. So probably a good place to start would be counting by ones. And again, if I decide to start being lazy partway through, skip one and then label the next, skip one and label the next, skip one and label the next. And what would be a good scale to count by here on the y-axis? Jackson. I would say 25s, because that's what we're counting by here until I did the weird thing, right? So I think that that is a great way to count. 25, which means the next one is 50. I'm going to skip one and then label it 100 and continue on. $2.50. Okay. Now let's plot those points. This is over 1 up 25. Yeah, yes, actually, thank you. I did mention that in my last class and I forgot to mention it here. I do, even though we didn't put it on the table, I want to include it in the table. What if I have a map distance of 0 centimeters? Well, that means that the distance is 0 miles. So yes, thank you for pointing that out, CJ. We want to include that origin 0, 0. Yep, 250 and 3,75 and 4,100 and 8,200. And what do you know it? This is a straight line that goes through the origin. Yeah, we didn't expect that at all, right? Okay. Let's come back together, settle back down. And you say I'm sarcastic. Y'all are just as sarcastic. That's why I have to be sarcastic to match you. What if, ladies and gentlemen, what if in the table I had an X? How would I go forward? What would we do to go forward? Gavin D. Nope, I have X. What am I multiplying by? Every time I go forward in the table, what am I always multiplying by? Luke? 25. So what am I going to do even if it's an X? I'm still going to multiply by 25. And we're on our way to an equation, so it sounds like I should probably be writing that down here. X multiplied by 25. I went across the table, so guess what column I'm in now? I'm in the Y column. X times 25 equals Y. Or I can write it in reverse order, Y equals 25X. Nope, X equals 25Y is not going to work. It's a different equation. All right, folks, let's settle back down. Remember, all of this is being recorded, and it gets to be really loud for those trying to listen to the online recording. So you guys need to keep it down. Only my voice should be going. What is the actual distance between two cities if they are 3.6 centimeters apart? How would I even answer this question? How do I use the information in our table and our graph to help? Talk with your groups and form a strategy. Okay, and voices off. Please come back and share your thoughts. How do I use the work that we've already done to help me answer this question about 3.6 centimeters apart? Now that voices are finally off, I'll ask that question again. Hopefully everyone will be able to hear it this time. How do I use our representations to answer this question? If they're 3.6 centimeters apart on the map, how far are they for the actual distance? Get me started, Gavin R. You're exactly right. Let me show my work and explain why. When it says 3.6 centimeters apart, guess where that information belongs? In the centimeter column, right? And I don't have space up there on the table, so I'm just going to kind of add it down here. So if I have 3.6 in the centimeter column, what do we do with that information? We go forwards by multiplying by 25. So this is the work that I would expect to be shown. 3.6 times 25, and then after I wrote it down on my paper, then I would plug it in. But I want to make sure I'm showing my work here. 3.6 times 25. Thank you for these hands. Thank you for the quick fingers on the calculators. Ryan, what'd you get? I'm sorry, that was so quiet I couldn't hear. 90? You guys all agree? Fantastic. 90 watts. Miles. Good. 90 actual miles apart. Okay, and now compare that to part B. If the actual distance between two cities is 360 miles, how far apart are the cities on the map? How is this problem similar and different? Again, quick 15-second discussion with your tables, and then it needs to be quiet because we're going to talk about it. 15 seconds, ready, set, go. I need voices off, thank you. And thank you, you got quieter much quicker that time. What would I do on this problem? Do I just take that 360 and multiply it by 25 like the last problem? What would I need to do different, Sam? I divide by 25 because this time I'm giving you the 360 miles. That means I'm giving you information that should be on this column. Very good. We can also multiply by the reciprocal. Fantastic idea. So if I give you information in this side of the column, I would have to work backwards and divide by 25. So in my calculator, I would type in 360 divided by 25. And good thing we all have calculators, so we can all type it in for ourselves and find that the answer is what, Emma? 14.4 watts. 14.4 centimeters on the map. Great job. Okay. I'm going to let you guys work on 2 and 3 with your groups. 60 seconds before we go over them. Give them a try. 60 seconds. Online learners, pause the video. Ready, set, go. Shelby has twin boys. She buys a box of 10 toy cars to share evenly between the boys. What do I do with this information, CJ? You got it. And I want to show my work in a very specific way, so I want all eyes on the screen. One thing that you need to understand is I need to see work on the review, and I need to see your work on the test. I'm going to show you the work that I want to see. I'm not asking for you to do long division algorithms on paper, right? I just want to know that what your thoughts are. We have 10 toy cars that we're sharing evenly between the boys. So that's 10 cars for the 2 boys. Where'd I get the number 2 from? It doesn't say the number 2 anywhere in there. Where'd you get that from, Berkeley? Twin boys. And because the problem is asking us to find the unit rate, remember how we've done this. We've shown our work. This is long back in the unit. There's a couple ways we can do this, okay? What is the problem really saying? It's saying 10 cars divided by 2 boys. So we could type into our calculator 10 divided by 2. But I also want to show our work a different way that's going to help us with the future problem, okay? When we're finding the unit rate, that's going to be per 1. Remember when we did this? And we said, how does a 2 change to a 1? We divide it by 2. We divide it by itself. So what am I going to be doing up here? The same thing. 10 divided by 2 is equal to 5 cars. And there's your unit rate. Notice what it says here, okay? In our calculator, in the very beginning, we could have just typed in 10 divided by 2. Or if we did it this way, we could have just typed in 10 divided by 2. Looks like it's the same no matter what, right? But if we show our work this way, it really does help us for a future problem. Have we answered the question, how many cars per boy? Yep, 5 cars per boy. Next one, let's go through it in the same way. I'm going to do a different number probably than what you guys did. I am going to choose this spot here on the table. Okay, it says push-ups per day, so that actually gives me a hint as to how I should set up the ratio. Push-ups per day means I want the push-ups to be on the top, and the per day means that's going to be on the bottom. So, push-ups per day, I'm using this stuff. You guys probably already did the problem using different ones. 435 push-ups per, how many days? 29. And again, what can we type in? It tells us right here. We can just go 435 divided by 29. But I also want to show my work. And we ask, how does that 29 change to a 1? Divide it by 29. Every number changes to a 1 by dividing by itself. So that means I'm going to take this 435 and divide it by 29, just like it showed in the beginning. And 435 divided by 29 is 15. So the unit rate, push-ups per day, how many push-ups per day? 15 push-ups per day. Constant proportionality, we have to work a little bit differently. We always want to ask, how do we go forwards in this table? How does a 2 change to a 30? Multiply by 15. How does a 4 change to a 60? Multiply by 15. Does it work here? We already know it's going to, right? Because we just found the unit rate using those numbers. And here, check it out. We know that the constant of proportionality is, what? You're telling me the constant of proportionality is the same as the unit rate? That's not news though, is it? We've known that for a long time. We've practiced that information. Fits. Yes, I could have divided 30 by 2, but since I know that you probably solved it by dividing 30 by 2, I wanted to show a different way of doing it and that we still get the same answer. CJ. Uh-huh. I know, right? Minds are officially blown today. Okay, here's the next part. It says for each of the following situations, find 2 unit rates. Take a look at what this means because this is something we haven't done in a long time. It says find 2 unit rates. For example, we could find miles per hour, but then we could also switch it up and find hours per mile. So I'll help you out with this first one. Finding the unit rates means I want to set up the problem something like this. 357 miles. Since it's a unit rate, I'm going to set up that ratio. So 357 miles per 10 gallons. And before I even do any work here, since I need to find a second one, look at how I'm going to get that second one. I'm going to simplify this one, but then I'm going to flip it to its reciprocal. Remember doing this? Where instead of the 10 gallons being on the bottom, now I'm going to flip it so that the 10 gallons is on the top. And instead of the 357 miles being on the top, now the 357 miles is going to be on the bottom. Okay, I flipped the ratio, but we're still not done because we need to find the unit rate, which means I need it to be per 1. And this one, I need it to be per 1. So let's do that. How does a 10 change to a 1? How does a 357 change to a 1? You know the calculations, so perform those calculations in your calculators. 10 divided by itself is 1. 10 divided by itself is 1, but since I'm dividing by 10, I need to divide by 10 up here too. 357 divided by 10 is 35.7 miles per gallon. And now, flipping that, how does a 357 change to a 1? We divide by 357. We always divide by itself in order to turn it into a 1, which means the 10 is going to be divided by 357. Who has those quick calculations? Quick fingers. Dakota? 0.028 gallons per 1 mile. Do you see this next problem? I'm not doing that one in the recording. You guys are going to have to do that on your own. That's your homework. Well, for now, anything we don't finish in class is homework. But for now, that's one problem that we haven't done together. I know it's easy. Now let's skip ahead to 6. Catherine is visiting patients in a hospital. She visits 12 patients in 6 hours. At the same rate, how many patients will she visit in 9 hours? I'm going to set this up just like the last one. 12 patients, 6 hours, and the question is asking how many patients in 9 hours. How does a 6 change to a 9 through multiplication? Does anybody know how a 6 changes to a 9 through multiplication? Not easy to figure out, right? But that's the beauty of this, is we don't actually have to know. Because if we really read the directions, it says use the unit rate. So the baby step that we should be taking is not how a 6 changes to a 9, but how does a 6 change to a 1? Can you change a 6 to a 1? Yeah. Could you then change a 1 into a 9? Yes. So when we take that baby step of finding the unit rate, it makes it so much easier. So a 6 changes to a 1 by dividing by 6, and then once I change it to a 1, I can then easily change it to a 9 by multiplying by 9. Whatever we do to the bottom, we have to make sure we do up here. So 12 divided by 6 is 2 patients. And we multiplied the 1 by 9, so I'm going to multiply this 2 by 9. And 2 times 9 is equal to 18 patients in 9 hours. Number 7, that's for you to do on your own. Let's move on to number 8. Wendy is making her famous chocolate milkshakes. Complete the table graphing equation to show the relationship between cups of vanilla ice cream and tablespoons of chocolate syrup. And here's the problem. I don't have any information to do that with. I do. Where is it? It's all the way down here, but it is there. How does an 8 change to a 16? Hagen? Multiply by 2. So what am I doing everywhere? Multiplying by 2. Even here, right? I'm going to multiply by 2. What am I doing right here on the table? Yeah, we have to divide. We're going backwards. So we would need to divide by 2. Yep, or we could multiply by 1/2. Going backwards here, dividing by 2. Going forwards here, multiplying by 2. So guess what? You guys get to finish this for your homework as well. I want to answer question part B here with you, okay? So we have to do one more thing to really be able to answer that question. I'm going to fill in this part of the table. 1 times 2 is 2. Remember how the first column is our x and the second column is our y? Okay. So with that in mind, when it says, what does the point 1, 2 represent? Remember, 1, 2 is x, y. What are we measuring in our x's? What does it say here in the table? Danny? Yep, cups of ice cream. So the x represents the ice cream. And the y represents chocolate syrup. So what does the 1, 2 represent? It represents 1 cup of ice cream and 2 tablespoons of chocolate syrup. And again, the rest of it is for you to do on your own. Like I said before, the answer key is going to be posted in Canvas, but you have to do your part and complete it and then check your answers. The last ones I'm not going to spend a whole lot of time on because this is just like what we did in our last lesson. Can we tell just by looking at a table if it's proportional or not? Yes, we can. Can we tell just by looking at a graph if it's proportional or not? Yes, we can. How about looking at equations? I'm going to just go over A and B with you. A, 11A. Is this proportional? No. How do you know? That plus 50, right? That adding 50. So this is no. The adding 50 screws it all up. We can't add 50. Yep, just adding in general. Part B is a tricky one. I don't know. Is it? 5y equals 40x. Is this proportional? Quick discussion at your tables. What do you think? Part B is proportional. Remember, as long as all we're doing is multiplication, are we only multiplying? Yeah. Am I multiplying on both sides? Yeah, but I am only multiplying. Take a look and see. If I wanted to make the equation look a little bit more normal, I could divide by 5. And whatever I do to one side, we do it to the other side. And 5 divided by 5 is 1. So we're left with just y. And 40x divided by 5 is equal to 8x. And now that looks nice and normal, right? Yep, so we can say, yes, it's the same as y equals 8x. Anything we did not complete in class together is homework. Anything not done on the video, you still need to complete on your own and submit in Canvas. That's it for today. Thanks for watching. We'll see you next time.